Machine did evolve from the 117, and I believe that a large amount of the design from this came from Heinz Janoschek Sr., who was the chief engineer in the Bernina Factory in the 50s. And his son, Heinz Janoschek Jr., is my old friend and favorite mentor. And he was the chief mechanic of this line of machine, and he was the one who developed all of the new features called the 217N. So here's an older 217 which is on the floor here, and it looks the same, but it has some major differences. But a lot of the internal parts are still the same, very high quality components. But anyway, that's kind of where that went. But the factory realized that there is the industrial market, which are machines that are made to function 24 hours a day. They have oil pumps and oil sump, so that they're automatic lubrication. They're very, very well balanced, so they can run speeds up to 6,000 and even greater. Some machines I've seen running something like 7,000, close to 8,000 stitches a minute, some sergers and so forth. And anyway, but the industrial machines are made for single application, not multi-function. When you build a multi-function machine, it would be very difficult and very expensive to make an oil pump, oil sump machine, because you have a lot of open spaces where you can't contain the oil and be just a big mess. And it would be overkill for that market. So the commercial market, which is the second market down, is a market for artisan sewers, people that sew, that want higher speed than a normal domestic sewing machine. So this machine's speed can range up to about 3,000 stitches per minute on, in machine bursts, like you would see if you're sewing like a 12-inch piece. You can buzz right through it, and then you can stop and backstitch. And but it's not made for continual running at that kind of speed. And so the factory lists the machine, I think, the maximum speed at 2,800 stitches per minute. It's probably the finest zigzag machine ever produced. But with the commercial type machine here, you have a multi-function machine where you have 9 needle positions for a straight stitch on the across the needle plate. You have, on this machine, is an 8mm zigzag. You have a 6mm stitch length, 6 or 6.5, something like that. And then it has the option of, and you can wind a bobbin on the machine. You don't do that on industrial. It's usually done on the table with a table winder. You've got a fixed hand wheel, but there were some hand wheels on this machine made. I have some that are releasable, so you can wind a bobbin. No, you can't wind a bobbin that way. I'm sorry, but it's a releasable hand wheel. And they had a table winder that would come with the machine on the earlier models. This one has a built-in winder here, and so, you just push this down, and then that's how you wind bobbins. You wind bobbins all the time. Okay.
Pretty standard.
And then you've got, you have a knee lift mechanism, which is pretty cool, because you have a lift mechanism where the foot will stay lifted up until you actuate it, and then it comes back down. This machine, the early machine from the 217, the earlier models used a 287 system needle, which to me is a useless needle, because the 134 needle, or that style of needle, is the same length, which is 33.9mm from butt to eye, but it has a 2mm shank, and the variety of needles that you can buy and that would be classified as a system, like a Schmitz package. You'll see that the canoe on that one, which is the internal stock number, will say 135X7, 135X5, so forth. I can show you a needle chart, a Schmitz needle chart. You can see what the variety of needles that you can get. You can use all types of leather needles. You can use the 265-50EOK, which is an embroidery needle, which is a ballpoint needle. All embroidery needles should be ballpoint needles. And quilting needles should be ballpoint needles because the application is a multi-direction. And the hook system in this machine is the best hook system worldwide, renowned for sewing in multi-direction. It's a fabulous hook system. The system was built on the Wheeler-Wilson hook system. And the hook is a lot more robust than the current hook systems that other machines use with their very, very thin camming gib. Hold on, I'm going to show you a hook here so you can see. So this is the type of hook system. This is a large one. This is a hook system. This one's out of a handy quilter sewing machine. This is called the gib, the sheet metal part. Mm-hmm. And that gib is what the gib does is the hook point right here is rotating like this, and that the gib then comes in contact with thread. It actually lifts the thread over the bobbin case. You see why this camming surface here. So, but the thing that's very fragile on this hook system is that the edge of this gib can get damaged quite easily with a needle. And if you can feel the slightest catch, it will pull loops on the bottom side of the material and it will break thread. But this part can be removed. There are 4 screws here. This one's missing. It can be removed and polished. And so what I usually do before, and even when I have a new hook, and you can see this gib here is super shiny. It's a better finish actually than the stock finish that the factory makes. But that has to be very, very smooth and rounded slightly. And you can tell, when you have a machine that's breaking thread with this type of hook system, always feel your fingernail on the gib and you'll be able to tell. That's about 90% of the problems with these things.
So one of the morals is don't sew over pins.
Straight pins, we have an example would be we have one of our students came in and the student damaged the hook. She had all kinds of needle penetrations on the needle plate. And she had a lot of damage underneath the fabric, or underneath, through the fabric on the hook itself. And I asked her, I says, "You sewing over straight pins?" And she says, "Well, yeah." "Oh, who told you could do that?" "My teacher." And I jokingly, I said, "Well, you can tell your teacher she's wrong. You can't, it's against physics to sew over a straight pin or anything metallic like that." I said, "You're going to damage the needle or you're going to cause the needle to hit something underneath the needle plate."
It's not uncommon. I've heard Nancy, someone with Nancy advocate that. So it's.
She says sew over straight pins.
Yeah, you mean you have to have them at a 90 degree.
Yes, but
I'm sorry, but
they're wrong.
They're wrong.
Totally. I mean that's.
If you're buying $129 sewing machines and you're going to replace them every 2 years, then maybe you can.
I don't even think a $129 sewing machine would last you 2 years. Probably not even half a year. Anyway, it's against physics, and you just don't go there. The other thing that you don't do is you don't backstitch over thick materials. Ever. Bring the take-up lever to the highest position like that. If I line up a tooth on the machine like this, on longest stitch length, when I rotate the hand wheel so the needle goes down, that tooth should advance about 1/3 to 1/2 of a tooth. That looks good. I think I have an abundance. I forgot about some parts I have. Right here is the adjustment for the height. And you'll be able to see.
What size screwdriver was that?
It's about a number 4 or 5. 4 is fine. Okay, you can see from the bottom side here, this is the clamp right here, and you can see this is the feed dog support or feed dog frame, lifting frame. And if we move this down, the feed dog goes up. If we pull it this way, the feed dog comes down. So that's what we're going to do here. And here we're going to, so I had to move it slightly loose so that we can move frame up or down, it's too tight here. Never make your adjustment with this something totally loose. And sometimes you can, but you want it to carry there. Actually, it should carry that in the front, but not in the rear, but right here. See, it doesn't carry it here. Okay, we're going to take this cover off. We have to do with a screwdriver because it's slipping here. And this one is Eric Enchman. Yeah. There's an interesting story on this. You have to turn your camera off. Right here, we're going to pull some things apart, and we're going to take, I'm going to get a little doodad here. Down back there.
What are you soaking them in?
That's just mineral spirits there. There's just a little bit material there that from left over. And take the foot off and this guy off. And these need to be adjusted out here and clean. And then
Okay, so you're using a longer one. I was wondering if I needed to get a shorter screwdriver for that.
no, don't go shorter.
Okay.
That feed dog is now let me explain something too about the feed dog. Years ago, and a lot of people still haven't figured this out. If you want to sew sheer materials, you cannot sew sheer materials on a zigzag machine if you have a double feed bar back here. Okay? One of the secrets to this machine, I can sew toilet tissue in this. If I hold the threads and I simply pull those threads, it's going to sew it. But I can sew all kinds of materials with this feed dog without having the material pucker, because when the take-up lever strokes upwards, it's pulling on the thread here, and you're trying to feed backwards. And if you have a slot through here, it's going to cause that material, you know, when the feed dog is pulling that straight stitch back. If you have a gap like this in the middle back here, the material will actually pucker. And so you're going to have your straight stitch is not going to look good. So anyway, that was one of the keys on this machine. That's Bernina never talked about it. I learned about it in my training.
It's that this feed dog is in a different shape, and so it doesn't have a place for the material to fall down into.
This is a solid component, and that made a huge difference in stitch quality. A simple thing like that. But all the machines made before that had double feed back here and the two long bars. So you had double feed in front, double feed. The old 217?
The old 217s, did they have the solid?
No, this actually came out on the
117?
117. See that? That's an original plate, an old plate.
What does my 730 have? I don't know. That's terrible.
So have a single bar in the back. Go here, 730. And this turns upside down, like that, comes out. And we're going to take the presser bar out. We're going to remove this, and we'll take these out, and we're going to tap those holes and put plugs in them. The reason being is that after we lubricate the take-up lever, you don't want to add any more oil to that. The lubrication is a long, very, very long lasting lubricant. It's a Kluber lubricant we're going to use. So, and I'm going to put a new presser bar in there just for fun. Okay, so here, let's take this off. Have to change my shirt. It was cool this morning. your job at the museum
Uh-huh.
would be something I would love to do.
Yeah, and you would be exceptionally good at it.
Think so?
Oh, yeah, definitely. You would be one of the
See here?
top guys.
There's a screw hole there and there. This brass screw is simply to hold that eccentric in place. Okay? This is an oil spot. Oh, you're going to use this screw and this screw for the lifting for the lifting lever or connecting rod as it comes through. This hole here is tapped and it's used to mount with a large screw the puller to the frame. This surface, even though it's machined off, is now changed in dimension because that's what cast iron does for a period of time until it's aged. So, anyway, we'll take that out, and right here we're simply going to unscrew this.
I have a vintage DeWalt radial arm saw, one of the old ones, and just research. I like to research stuff like this. They would just throw them out in a pile. After they cast them for a year, I think.
Oh,
and
you get rust on them, everything.
This is rust on them. There's out in the rain or whatever, and then they would do everything.
Yep. Yep, that's what they do.
So,
Matter of fact, this old milling machine bed was laying in the field when I belonged to the machine company that I bought the milling machine and lathe from. This little lathe I have is a pretty good little machine. It's made in Austria. It was initially called Royal Steel or Edelstahl, and they were made in Brazil.
go ahead and take the call.
Okay, we're going to remove, we're going to take out the needle bar frame. Pull this needle out. And the way I do it here, we're going to pull it out enough so that I can get some parts out. Then I have to remove the lifting lever for the tension, the release lever. They're tight. And on this screw, one moment, we're going to fix this before I put it back in. So what I'm going to do is put that in here. You know, this, I had 4 pedestals in here. And I thought, I don't have room for that. So I added 3 of the tools on here. This is a high-speed sewing machine motor. And it's, I made it like a jet engine. And, but anyway, made to save myself a lot of room there. All right, so here we're going to pull out the hook body. I'm going to turn this way. Make it easier to get it out of the way of around here, and then we're going to pull out the hook. First, we got to take out this is, excuse me. This is the stop fork.
And what does that fork do?
It keeps the bottom case support, or some people call them a basket here in America. That's this component here from spinning. This guy.
Okay.
See, this one is tight in the machine already. It should be free, and it's not. So here we're going to pull this out. And we can look at the shaft, and we can tell on the shaft if this has been removed before. But you can see it's had its problems with, let's see, let's go along, all the way up, and all the way back so we can get this off. The thread hanging on there. You see all the damage here? That's from needles just just rotating and getting in the groove and like that. So the needle's supposed to go in here, not back here.
And that was caused by hitting pins, deflecting on the backstitching over.
Yeah, a number of things. We'll go through that.
Is that hook salvageable still?
Yeah, sure.
A lot of thread in there.
Big old wad of thread.
It wasn't letting the hook go. It was kind of hanging on to it. So,
Is there any way to get the thread out without removing the hook like that?
well, not this, no.
Yeah.
But I mean, taking a hook in and out of this is not hard.
Okay.
Set stitch length to the longest length and then rotate the hand wheel so the feed dog's back, and then you should be able to rotate the hook at a given point and remove it. And okay, so with that out of there, we'll be able to clean and we'll be able to change the lube in there. Now let's take this out. So we have a screw up the top, and we can then pry that out. And by wheeling the hand wheel back and forth, you can see inside here. We want to get this this pin out of the needle bar driver. Okay, there we go. And so now we've got to remove this guy. Yep. Now we should be able to stitch length.
And of course, if I was doing this, I would take photographs of every single operation so I know how to put it back together again.
See, this is way tight here. So we have to do some cleaning on this guy.
Okay.
Okay, we're going to take the take-up lever out, but we're also going to clean out right up on top here. That's a little bit too tight. Parts falling off your machine. This is an adjustment here, and you can see inside, if we push this down further, this is the adjustment here actually, and this is simply fixing collar. And this brown residue in there, that is from probably here, and you can see how worn that is. This is totally worn out. We'll have to replace that. You see, look at the gears, you can see they're bad. That's what this orange stuff is in there. It's oxides. Got pretty hot. What I'm going to do is I'm going to leave this adjustment as it is, and I'll be making the adjustment on this when we get it back together. It's a little easier to do. Loosen those two. This lever then comes out, like so. Okay. Now, we're going to remove, we're going to pull this guy out because we have to change that. I hope we can get this done in a day. Yeah, wrong tool.
I'm so glad we sent this here.
Okay. Underneath here are two screw holes. There and there. This is the one we want, and this guy is a fixing screw on this shaft. The shaft is an eccentric shaft. And okay, we'll loosen that. That was already loose, actually. Now with that loose, we are going to then remove that shaft out. See, it's already loose here, so it shouldn't be hard. So what we'll do now is we'll loosen the screws on these guys. Or just take them out. There. And there. And there. You kind of see why the charge for the general service on this machine is, when I look at most of these machines, it's not a simple thing. I have to get a hammer, a really soft hammer. Another Max Bauman hammer. Okay, so at this point, we're going to have to knock that thing out of there. Should have saved the hammer. So what I'm going to do is just put you can see the screwdriver in here. See that? That's on the end of the axle here. Knock the axle through back. This. And you can see the damage on that that's done to the teeth there. What's worse, this gear too is damaged. I have to pull the main shaft to get that out.
Do you have these parts?
I do.
Are these new old stock from Switzerland, or are they the Chinese making them?
No, these are for OEM parts. I don't have any Chinese parts.
Nice.
They're not Chinese. I don't know where Global is. They're having their parts. They are very good at reverse engineering.
Yeah.
And they built a really nice machine.
Yeah. Have you seen one in person?
No, but I think I've seen some parts.
Yeah.
Are identical.
Yeah.
And they may have even purchased from Bernina the drawings and solid models for this machine.
It's not crazy money either. Like,
They made a combination though on their machine. They made a long cover like this on top,
Yeah.
but they don't have a winder in it. And but they made a combination between the old machine and the new machine.
yeah. I think it's something like, I think you can get them for under $3,000, which
2000. I can buy them wholesale actually.
yeah. So they're not like, I mean, for what people pay for brand new computerized Berninas, they're a bargain.
Yeah. Okay, and down here is the other screw on the bottom there for the gear cover. And that's the original grease. We're going to replace all that. There's hardly any in there, in fact. So, but here, you're still tight. That's good. And the other thing I'm concerned about is if somebody's thinking, you can see how there's damage on the screw there. Somebody's horsed around with that. So let's get in here and take that loose and look at where that's a conical screw and it fits into a groove. I thought there was something wrong. No groove. And that's why the timing is a little screwy. Here, this one is. And usually it's a dealer that does this. Have no idea what they're doing. And we're going to have to take this one out too. So. Conical screw, and let's see what we've got inside that. Ruth, are you getting bored?
No, not yet. I'm still enjoying
Not yet?
working.
Oh,
No,
is it
she-
coming?
No, she actually wants to learn this. I don't know if she's going to be pulling the main shaft any soon.
I'm not doing this level of detail. I like knowing how it works though.
Okay, you see that? You've got some screw marks from the, we're going to have to deal with those screw marks. I don't know if you can see through the hole there.
Focus. I'm not really picking it up, but yeah. So on the shaft, there's
The shaft has been marked.
It's
by the
marked.
screws are hard, so the shaft's been marked. So we're going to have to fix all that. And that's the most common issues that we find on these machines is the fact that they get into the hands of dealers who haven't, even Bernina dealers, have the slightest idea how to deal with this machine. Oh, that's interesting. So this has even been apart. And wrong screws on the flat.
Do you magnetize those screwdrivers?
Yeah, demagnetize them.
Nice.
Yeah, they're good for that. Okay. So we're going to take, now we're going to pull out, loosen this gear. And we have that one. And we've got this one here. Come back here. And this one here. Hard to get to. Yep. Got this screw. This is a collar that holds everything where it's supposed to be. Okay. Then we have this guy here, which is the adjustment of the eccentric. That is the eccentric, actually. Let's turn it all the way around so we get that. There we go. Okay. Next, we've got we're going to take the take-up lever out. And what I want to do, though, is in this case, I'm going to want to make more clearance on this. So we're already loose here. And let's take this all the way up if we can. Yeah, we'll do it this way. Pull that out there. This is way more than what you're going to have to go into unless you want to rebuild these machines.
No. This will be Ruth's, and I have mine, and we hope to keep them running for the rest of our lives. And since we're just amateur sewers, I can't imagine that we would wear something out like this out.
You're too amateur. I think you underestimate. I can tell.
Well,
Some of the things you've done, what you're capable of.
We both do things well,
Yeah.
and learn the proper way to do things. I think that's
slow.
See that?
But we're slow.
This crank in here, this has been tight up and down, so that's going to have to be repaired. Move that out of the way and push this through, and see that guy is stuck too. And that's not good.
I'm so glad we brought this here.
I almost can get in there and jam it, but I can't. That is stuck.
Is that oil varnish, you think?
It is oil varnish for sure, but you can get that out of there. Just a little lacquer there.
The Home Depot brand, I think you were saying.
Yeah. I think that stuff is good. Their mineral spirits has changed. It hardly even evaporates. It actually will stay on the table longer than water. Kind of dumb, but the way it is. Okay. Okay. Once we break it free, we're also going to take this one out of here. Might be easier to just take it out like that. Come on. Ugh. We'll clean all these parts up. Okay. See, that guy's stuck. Really sticky. That has to be freewheeling. And this guy, that's stuck there.
Wow.
So that has to be fixed too. This is a precision alignment, so don't ever bend that.
Yeah.
That's the hardest thing there is to rebuilding, to making a long one in the Legacy machine. Legacy 1. Legacy 1A doesn't have a it's fixed for straight stitch. We'll fix that later. And here, let's take this guy out. This will have to be cleaned out. But I think what we ought to do is just remove that too and clean that. This is your zigzag adjustment here. And this whole crank. And then we've got this guy here. We're going to look at it for damage. And so it helps to loosen that screw. There's another screw underneath here under this guy. Right here. Usually replacements I use Allen screws.
Mm-hmm.
I'm not trying to search. I don't know why they use Philisters, because worldwide Philister type screwdriver is what people have.
That makes sense. When we ship artwork, we have to be careful what kind of screws we put on cases. I mean, we're sophisticated. We have every known, and there's a bunch of weird ones in the world of there's the Robertson and the Phillips and the Philisters, but then there's all these other ones, and we can handle any crate that comes in.
Yeah.
But we've had issues sending artwork out where they didn't have a simple square drive.
Really?
Yeah. And so we have to be very careful about what screws we use.
Yeah.
So, especially with foreign. Whenever I send a mount out, I send every single tool that the courier needs to install it, including drill bits, Allen, anything. You would assume that they would have at the other museum, but you just can't.
Yeah.
So I just give them a little kit. It's got the mount and every single plus instructions, templates.
Normally I put another tool in there first, but I didn't do it here. A puller, actually, comes out like that. Okay. Okay, let's take these out. This and that is stuck on that one too a little bit. There we go. Okay. All right, take that out. These, when they were made, have a zero finish on them. You familiar with finishes?
No.
Okay, when you're making parts, on a part drawing, if you're making a part and you have to have a certain finish for bearing quality and it's hardened, then you have I think I have a little finish over here. Those are finishes. Okay? This is a finish. The finish that I can put on it is the factory does is better than this, because it's like a mirror. You can see your face perfectly in it to the smallest detail. And this is what they call a 2 finish, and this doesn't go to 0, but a 0 finish is as perfect as you're going to get. And we can actually do that with a buffer. The factory laps those in. This is a very expensive part to make. And on the part, usually, let's clean that up for a second.
And that's one of the parts you change if you're changing the stitch width. You know, if it's a 12 millimeter.
This is an 8mm zigzag
Yeah.
part here. And see a little mark there? This little looks like a blend there.
Mm-hmm.
There's one there, a different spot. And here is one here. A little dimple.
Mm-hmm.
Okay. These are made to fit the eccentric, the cam that fits in a triangular cam. There can't be more than 3 10,000ths clearance at any given point when that cam rolls in this. That's the precision of this machine. It's incredible. And what will happen is when these parts are made, they're not made to that. They try to hold that kind of precision, but you know, you're never going to get there like that. So the fork can be bent out like this, so it's narrower here and wider here, or it's narrower here and wider here. So when you fit it on the part, you can take the eccentric. The cam is good. Yeah, it's got some wear. So when they fit it on there, you can see here, we're tight. Okay? And down here, we are loose. So up here, we're tight. So if we want to make this fit better, we can do this. I can take this guy like this and hold it on there. Come on. Get the surface on there that I want. Right there. Teensy little mark. A little bit more. So something's changed in this machine from factory. It's almost there.
Don't try this at home, kids.
No, I'm just demonstrating something here so you can kind of get an appreciation for the product that it is.
Oh yeah.
These are handmade machines. And they're the finest zigzag machine ever produced. Industrial or domestic, or in any form, I guess. So here, I overdid it. And I can actually feel some play in the part. You can see it a little bit move. Down there too. So if I have to move the points together, we do this. You see? And it's moving in tens of thousands. But that's how they're adjusted. And so you'll see tool marks on the part in the machine.
From when it was originally manufactured and put together.
Yes. And I don't know any machine company that would do things like this, but Bernina they put a lot of effort and workmanship. We're going to replace these two components. Steel cosmoline or